I just asked today's guest, Shannon, where the best spot in Sitka is to find clams.
And we went to this beach and we put the pitchfork in, and just so many clams, so beautifully sized. I like the mid-size ones too, and it was just so many nice mid-size ones. I think in that first scoop down kick up, we got 20 butter clams, little necks, and cockles, and it was just the most gorgeous beach. There was a little estuary in the back with grasses and everything. But I don't know where it is, so I couldn't tell you.
Oh, okay. Oh, wow.
But it was close to town. All these little islands have,
Okay.
Have pretty good beaches, and oftentimes you'll see the leftover shells. That's a good indicator that the beach had clams on it. If you see the little holes on the beach, that's usually where their siphons were. So
Seem like the water squirts up.
oh,
sometimes.
that's a great indicator that they're trying to burrow down even further.
Does that mean they're happy to see you?
I think that means, oh no, somebody's coming.
Paralytic shellfish poison. Have you ever heard of it before? Have you ever eaten a clam, oyster, mussel, any kind of shellfish, cooked or raw? I'm Jeremiah Murphy, and this is Mariculture Minute, a podcast about shellfish, seaweed, and salmon right here in Alaska. Today we'll talk with Shannon Cellan. Shannon works for the Sitka Tribe of Alaska at their lab. I'm talking to Shannon about paralytic shellfish poison because, well, it scares me. I admit I'm afraid to eat shellfish, and Shannon makes sure it's safe to eat. So I'm very eager to hear what Shannon has to say. We're going to talk about what paralytic shellfish poison is and how Shannon tests for it. But first, I have here an old scientific report published on July 1st, 1956. Hold on to that date. The typewritten pages are yellow and smell like a log cabin you might stumble onto deep in the woods. The report's title, Public Health Significance of Paralytic Shellfish Poison, a review of literature and unpublished research. The authors are from a few places: the Robert A. Taft Sanitary Engineering Center in Cincinnati, something called the Milk and Food Program out of Washington, D.C., and there is even a member of the Army's Chemical Corps. Page 9. The first recorded death ascribed to paralytic shellfish poison on the North American continent occurred on June 15, 1793, on Vancouver Island, British Columbia, when one of Captain Vancouver's seamen died after eating roasted mussels. There is reason to believe that this was not the first death due to paralytic shellfish poison, for Vancouver wrote that his crew members had some idea of how to treat the stricken seamen, thus indicating prior knowledge. In 1799, a troop of Aleut hunters from Unalaska and Kodiak, stopping at a place now known as Peril Way near Sitka, Alaska. Hey, that's where I am now. Consumed mussels, and according to Petroff, 100 men died in less than 2 hours. Page 14. The symptoms of poisoning in human beings are primarily peripheral paralysis, which may vary from a slight tingling and numbness about the lips to a complete loss of strength in the muscles of the extremities and neck, and to death by respiratory failure. In a moderately severe case, the tingling, stinging sensation around the lips, gums, and tongue develops about 5 to 30 minutes after the consumption of the mussels. This is regularly followed by a numbness or a prickly feeling in the fingertips and toes, and within 4 to 6 hours, the same sensation may progress to the arms, legs, and neck, so that voluntary movements, as for example raising of the head, can be made only with great difficulty. In all cases of moderate severity, this toxic weakness and stiffness of locomotion is accompanied by a peculiar feeling of lightness. Some patients have declared that they experienced a floating or flying sensation, and even heavy objects appear to them very light. And the report continues. The longest recorded interval between eating poisonous shellfish and death is 10 hours, and the shortest interval is 3 hours. So now I'd like to formally introduce Shannon.
My name is Shannon Cellan. I'm the lab manager over at Sitka Tribe, and I am in charge of the lab that does the paralytic shellfish toxin testing the ocean acidification research, and we also have other projects that come in and out depending on grant funding. So we've looked at other toxins of concern like diuretic shellfish toxins as well as domoic acid. We've looked at mercury. We are starting to do some European green crab surveys. They're an invasive that's starting to come up from Washington, BC area, so keeping an eye on that. And basically any other project that feels like a priority to Tribal Council.
As you can tell, Shannon does a lot of cool stuff. I want to talk about some science terms Shannon is mentioning. Let's start with the basics. We've used the word toxin and the word poison. Do you know what the difference is? I just found this out myself. A poison is a harmful substance. In large amounts, it can make you sick or die, whether you eat it, breathe it, or absorb it, like through your skin. Creepy, right? Some examples include alcohol, which can be a poison in large amounts, carbon monoxide, the gas that comes out of your car, can be a poison, and stuff you hear about in movies like cyanide. Toxins are poisons made by living things, animals, plants, or in this case, algae. We're talking about poisons made by organisms, toxins that shellfish eat, and that we could eat if we eat those shellfish. Paralytic shellfish toxin. And here's Shannon talking more about this stuff.
So a little breakdown of what's happening in our body. Our bodies have sodium ion channels, right? And that allows us to use action potential to move our muscles and function.
That's how our body works.
Right, exactly. So the sodium ion channel allows this sodium to go through. When there's paralytic shellfish toxins, which are saxitoxin, and then there's other like goniotoxin 1, goniotoxin 4. So they're just different structures of the same concept of molecule, basically. They will plug up that sodium ion channel. So then that sodium can't go through and you can't use your muscles, and that's why you get tingling, and the ultimate cases lead to fatalities, and that's because your diaphragm function ceases to work, right? So you can't inhale, exhale, and people aren't able to respirate, and then will die. But all of the toxins will behave in the same manner, so they're all plugging that sodium ion channel. The strength of how they bind or the length of time they bind is going to be a little bit different just based off the chemistry of that molecule.
So if I'm hearing it right, our bodies have this chemistry that we need to work. This sodium ion channel is one of these chemical processes. And what these paralytic shellfish toxins do is they get in the way and block it. It kind of reminds me of when I lived in New York City and I would hail a taxi cab and somebody might steal it. Saxitoxin, paralytic shellfish toxins are stealing our cabs.
They all come from phytoplankton. There's some cyanobacteria that produce them as well, but we mostly see here Alexandrium, and literature says predominantly Alexandrium catenella is the phytoplankton species that we see that's producing paralytic shellfish toxin. So our understanding is that one species of phytoplankton can produce multiple types of toxin. It's just one of their byproducts.
So paralytic shellfish toxins come from phytoplankton. Phytoplankton are tiny, tiny, microscopic organisms that float in the water and get their energy from the sun using photosynthesis. Shannon also talked about cyanobacteria. These are a type of phytoplankton. Sometimes people call cyanobacteria blue-green algae, but they're bacteria and not algae. Cyanobacteria can produce paralytic shellfish toxin. Shannon mentioned Alexandrium. Alexandrium is algae and another type of phytoplankton. Alexandrium produces saxitoxin. Excuse me, my throat just clenched up thinking about it. Saxitoxin is a paralytic shellfish toxin. It's one of the big ones. When lots of harmful algae, like Alexandrium, grows in the water, it's called a harmful algal bloom. Scientists call them HABs. Fun fact, at night, some types of Alexandrium glow if you shine a light on them. But when there's a whole bunch of Alexandrium in the environment, don't eat the clams. Speaking of which, let's talk about the testing process that Shannon does at the Sitka Tribe of Alaska.
Great. So what happens is communities or individual harvesters will send us samples to have tested. We have them fill out a form that says the day it was collected, the beach it was collected from, and then we're going to take those shellfish, shuck them to get the meat out. We're going to smash them up. So we need at least 6 individuals and 100 grams minimum of the shellfish to get a representative sample of what we assume people would be consuming. And that's based on FDA regulatory limits. Yeah, and our community organizations are incredible. Again, this has been going on for over a decade now. So the tribal environmental staff at tribes throughout Southeast Alaska and on the Kodiak Islands go out and collect samples, and they monitor every other week. So they're going out and getting blue mussels from their beaches and sending them to us, and we're giving them reports. And we can map these trends of, so many different communities and also Southeast as a whole. So it's really cool information that takes a lot of hands.
Wow, this is really useful information for people who go out there and collect their own mussels and clams to eat for dinner. I asked Shannon if there was anywhere that somebody could go and see this data. Are there any maps or anything that can warn them of where not to get clams or mussels?
Yeah, so that's where it gets confusing. That is on the SeaTour website.
Okay.
So that's seator.org.
Okay.
And there's a map that'll show you different sites, as well as a little list graphic that will kind of just break it down. If you don't want to look at the map, you can see by region, like northern, southeast, central, southeast, Kodiak area, and you can see the advisories in place. So it'll give you an advisory that says, the last time we tested something, it was above the regulatory limit. We don't recommend consumption. Some things are above, and then we have ones that say, we tested very recently, nothing was above, but caution is always advised when consuming wild harvest. We're only testing for paralytic shellfish toxins. Blooms can happen kind of hot and fast, and also sometimes I hear people harvesting places, and I'm like, PSTs might not be your concern, but I don't know if I would want to harvest there because of like outflows and other things.
You're talking about like sewage?
Yeah, or just other concerns. Like Stargavin North is downstream of the shotgun range, and I've totally harvested there, right? Yeah. But we're not testing for lead or anything. So
I really enjoyed talking with Shannon. It was super cool she had the time to be on the show. We talked about paralytic shellfish poison, what it is, where it comes from, and we started talking about how the Sitka Tribe of Alaska tests for it. In the next Mariculture Minute, we'll talk more with Shannon about the testing process and maybe get into a little mystery I spotted on that old report I read in the beginning. I'll include links in the show notes, both to the testing map and data, but most importantly, I'll also include a link with information on how to submit your shellfish samples to be tested if you're in the Sitka area. Both links are on seator.org, that's SEATOR.org, seator.org website, but I'll provide the specific links in the show notes. Thanks so much for listening. I'm Jeremiah Murphy. Mariculture Minute is made possible with support from Alaska Sea Grant. Special thanks to University of Alaska Southeast Sitka Campus, Professor Angela Bowers, Aldo Griffo-Hahn, Sarah Ebersol, Brenna Hackinson, and Walden Murphy for providing the music. If you'd like to find us online, you can type in kelpshow.com. We're also on Apple Podcasts, Spotify, YouTube. I have a podcast page now on YouTube. And you can find us on Instagram at Kelp Show. I've been posting pictures and recipe ideas and episode updates there. Thanks so much for listening, and stay tuned to the next episode.